Welcome everyone to another episode of West Explains Best. Today we're going to be doing another Kuta software worksheet tutorial on adding and subtracting polynomials. So let's go ahead and jump right into it. Here we have 6a minus 3a squared plus 2a minus 3a squared. What we need to do here is combine like terms. Anytime we have like terms are anything with the same variable raised to the same power. I know it doesn't look like either one of these is raised to a power, but there's an implied first power with both of these a's. Even though the coefficients in front are different, it doesn't really matter. It doesn't matter at all, actually, because we're just concerned with the variables when we're talking about like terms. So what we're going to do here is we're going to rewrite the 6a, and we're going to write the 3a next to each other. Make sure that you keep the sign in front of the 3a. Now, before you copy this down, one thing you need to know is the sign in between the polynomials. If it's a positive sign, plus sign, you're going to leave these guys in the parentheses that follow that plus sign exactly how they are. If it's a minus, you're going to have to do something a little bit different, but we'll get to that in just a second. Okay, so now we have identified those like terms. Here we have an a squared. This is an a squared. Even though there's a 3 and a 2, it doesn't matter. We're going to copy down exactly how we see it. We don't see any sort of sign in front there, so we don't need to distribute. And we're just going to copy negative 3a squared and then positive 2a squared. Essentially now what we're doing is adding or subtracting. So here we have 6a minus 3a. We're really just going to do the 6 minus the 3 to get the 3, and then we just copy down the a. The a is almost like an identifier. If we have 6 apples and we subtract 3 apples, how many do we have? We have 3 apples. Now, of course, a is not the same thing as a squared, so we have to do the a squared separately by itself, but we follow a similar process. We have negative 3 and 2. That gives us a negative 1a squared. And so we have 3a minus 1a squared. We should write this in standard form. Standard form is when you write it in descending order, so we have of powers. So we should put the highest power first, followed by the next highest power. So the a squared goes first, even though it's negative, and the 3a goes second. All right, let's do number 4. So number 4 is another good example. This time we notice we have a minus out in front. So before we do anything, we should distribute the minus to both terms inside and change the problem so it looks a little bit better. Minus 8. There's no minus out in front there, so we can just copy down 2a squared plus 4a cubed, how it is. Now let's identify like terms. Let's start with the highest power. Those are going to go first. So here we have an a cubed. There's an a cubed. So we're going to write 4a cubed minus 3a cubed. Here we have a squared, but there's no other a squared, so we're just going to copy him down by himself, and he's going to be all set. And then lastly, we have the negative 8. Again, there's no other negative 8, so we're going to copy him down, leave him by himself, and then we're going to simplify. So we have 4a squared minus 3a squared. That gives us cubed, 1a cubed, plus 2a squared minus 8. We don't need the 1 in front of the a cubed, so we can erase it. It's in descending powers. And there's our final answer. Let's skip over to the left side. Pardon me. I always seem to sneeze when making these videos. All right. So moving on to, let's go down to number 9. Number 9, we have more going on. It looks like, oh, this is a different problem because there's 3. It's the same process. We're still seeing if there's a negative, and there is. So we're going to distribute this to all 3 terms. 1, 2, 3. Actually, that was pretty good. And we're going to rewrite negative 11p to the 4th minus 13 minus 16p squared. It hasn't happened yet, but if there's a minus 13 instead, the minus and the minus become plus. And so essentially you're just looking at changing the signs of everything inside these parentheses to the opposite if there's a minus sign there. Okay? And we did that. 11p to the 4th was positive, became negative. 13 became negative. 16p squared became negative. So we just copy this down. There's nothing in front of the parentheses, and we're ready to go. Okay, now we're looking for like terms. We have a p to the 4th here. We have a p to the 4th here. We have a p squared over here. There's no other p squared. There's no p to the third power, but there are some constants, which is negative 13 and positive 11. We can go ahead and rewrite this, 10p to the fourth minus 16, oops, I forgot the minus 11p squared, minus 11p to the fourth, I said squared, you know what I meant, minus 16p squared, and then minus 2. Okay, final step, we're simplifying this. The only thing we really need to simplify is here, and that becomes negative p to the fourth, negative 1p, but you can just write the negative, minus 16p squared minus 2, and that's our final answer. Let's do one just to be thorough. Let's look for a really tough one. Let's say, all right, number 17 looks like a doozy. Let's go ahead and do that. Now, when you start doing this over and over again, if you write it over and over like we've been doing, we've been taking this extra step to write it, I would recommend doing that until you got it. Once you understand it and you're good and efficient, then you don't need to do that as much anymore. If you want, you should always distribute this though and rewrite anytime there's a negative out in front so you don't make mistakes. I see students all the time making mental mistakes because they don't rewrite the problem. Here we have negative, negative becomes a positive 11. Again, a negative times a negative AR to the fifth is going to be positive AR to the fifth. Then we have negative 6R minus 9R to the fifth. And here, I'm just not going to rewrite this. I'm just going to leave it, but I'm going to identify like terms. So let's go ahead and we're going to highlight this time. So let's start with our highest power. Our highest power is a... Whoa, that is way too dark. I'm going to underline, I guess. Okay, R to the fifth, R to the fifth. Any R to the fourth? No. Any R cubed? Yes, plenty of that. We have an R cubed here. We have an R cubed there. Okay, let me use 2 so it's a little bit more differentiated. Okay, next up, R. Or R squared? We have no R squared. Do we have R? Yes, we do. We have an R. Let's do one line there and one line there. And do we have any constants? Technically R to the 0 power. We have one here dotted. We have one here dotted, and that's all of them. Now what I'm going to do is in pink, I'm going to start with my highest power. So I have 8R to the fifth minus 9R to the fifth. This part I do in my head. Once you do this with practice, then you can do it in your head. So I'm going to get negative R to the fifth. Next up, my purple, 8R to the third minus 5R to the third is positive 3R to the third. Now I'm doing my green. 6R minus 6R is 0. I could write plus 0R and then simplify later, but what's the point? 0R is the same thing as 0, it just goes away, so I'm not even writing it. Then I have no other variables. I'm moving on to 2 plus 11, I get positive 13. There's my final answer. I would recommend writing it in one color, but you get the idea. Hope you guys found this helpful and it was a little bit more clear, and I'll see you next time on West Explains Best.